Alright, welcome back to the second part of Trig 1.8 or Pre-Calc 4.8 notes. As we left off from the first video, we were discussing how to draw bearings, and that information is going to be important to help us draw the bearing for this problem here. So we've got an airplane that is flying 550 miles per hour, so that's a rate, that is not a distance, from a bearing north 52 degrees east. So let's take our north, south, east, west lines here. North, south, east, west lines. From the north line, so from this line here, we need to head towards the east line, 52 degrees. This would be the angle that is 52 degrees here. So this is the line that our plane is flying down. So this would be our plane. After flying 1.5 hours, how far north and east has the plane flew from its point of departure? So here's where it departed. We want to know what is its north distance, we'll call this n, and what is its east distance. That would be this distance up here, the east distance. We've got a right triangle there now. So I need to go over and look at the fact that I had 550 miles per hour, and I have a time of 1.5 hours. So if I use the distance formula, my distance would be equal to the rate, 550 miles per hour, times 1.5 hours, which is good because I'm using the same unit of time here, so they'll cancel out. And 550 times 1.5 ends up giving me 825 miles. So I know that this distance here, the hypotenuse, would be 825 miles. Again, a common mistake that students will do is they'll put this down as 550 when that's a rate, that is not a distance, and that's what I want to know, is how far has it flown, flew. Therefore, that would be 825 miles. So, I need to do two things here. I need to find the north distance, and I need to find the east distance. So since I have a right triangle, we can use SOHCAHTOA. Let's start with the north. If I want to try to find this side, according to this 52 degree angle, that's the adjacent side, and the only side that I know is the hypotenuse. So I'm going to have to use cosine. So the cosine of my angle is equal to adjacent side n over hypotenuse 825. Get rid of that 825 by multiplying. We end up having the north side, the distance that we have gone north, would be about 508 miles. If we think about east now, I want to know this distance here. So again, sticking with my triangle, from this angle, that would be the opposite side now. And I know the hypotenuse, even though I know the adjacent side, that's an approximate answer, that's rounded. I don't want to use that side. So we would say opposite hypotenuse, that's going to be sine. Sine of my angle is equal to the opposite side, east, over the hypotenuse, 825. So again, we get rid of that 825 by multiplying it. Again, make sure, and it should still already be like that, but just in case, make sure your calculator is in degree mode. And this time we're going to get the east distance to be about 650 miles. So those would be my two answers. Alright, looking at the next example, you'll notice that I've already drawn the diagram for you. The diagram can be kind of confusing, so I'm going to take the time to go through and explain how I got the diagram. So what we have here is it says that Milwaukee, Wisconsin is directly west of Grand Haven, Michigan. So I drew Milwaukee here with the M. I drew an east-west line here, and I put Grand Haven, Michigan there. So then what I did was, because that was an east-west line, is I drew in these north and south lines going through, so I could come up with some angles, or I could put the angles that I have here into the problem. It says, on a foggy night, a law enforcement boat leaves from Milwaukee, so from Milwaukee, on a course of 105 degrees. So there is no directional bearing with that. Whenever there is no directional bearing, it's assumed that we're going from the north line and we're heading just like we would around the hands of a clock, so in this case we'd be heading towards the east line. So that's why I've drawn this angle from the north line going all the way, and I'd have to go past the east line because that would be 90 degrees, and I have to go past that. So with that being said, if this is 90 degrees here, how much further past 90 degrees did I go? Well, 105 minus 90 gives me 15 degrees. So that means that this angle inside of this triangle here is 15 degrees. That's going to be useful information to us. Alright, let's keep reading. At the same time, a small smuggling craft steers a course of 195 degrees from Grand Haven. So again, we're assuming, because it doesn't give us directional distances, we're going from the north line, we're heading like we would on the hands of a clock, we're heading east. So we start going around this way, that would be 90 degrees, this would be 180 degrees. How much further past 180 did we go? Well, 195 minus 180 gives me 15 degrees, but that's not the angle inside, that means out here is 15 degrees. So what would this have to be? Inside of the triangle, if that's a 90-degree angle, 90 minus 15 gives me 75 degrees. So inside of this triangle, that angle is 75, and this angle is 15. Okay? So what would this last angle be? Well, 15 plus 75 is 90, so this has to be a right triangle, because that would leave this as 90 left over. Whoa. Let's try that again. Alright, so we've got our 90 degree, now we have a right triangle, which is going to be good. We can use SOHCAHTOA on this. It says the law enforcement boat the law enforcement is traveling along this side from Milwaukee, 23 knots, and collides with the smuggling boat. So here's what I know. I know that the rate in this case is 23 knots. So in the distance equals rate times time formula, I plugged in a 23 for the R. I don't know the time, and I don't know the distance. Over here, I don't know anything about the smuggling boat. I'm trying to find the rate. I'm trying to find R. Well, what I do know is that since they left at the same time, whatever the t value is going to be exactly the same. So what I can say then, that this distance would be, this side of my triangle would be 23. Let me put that in a different color. 23t, because it's the distance that it's the rate that it's traveling times the time. This side of the triangle would be its rate times its time, and I don't know any of those, but I do know that the t's are exactly the same because they've been traveling for this. They left at the same time. So now, as I look at this, if I'm trying to solve this problem, I need to use these two sides. So pick one of the angles. Let's say that I pick the 75 degree angle, and it wouldn't really matter. You could pick the 15 or the 75. I'm just choosing to go from here. That means that this 23t is the opposite side, and this RT is the adjacent side. I can use then tangent of my angle, because tangent is opposite over adjacent, to help me find what the R value is. So opposite side over adjacent side. Now remember, we've been saying that since they left at the same time, whatever the t is, whether it's in 1 hour, 2 hours, 3 hours, doesn't matter what it is, it's exactly the same. So they're going to cancel each other out there. And so really what you're trying to do now is solve for R. So we're going to multiply both sides by R. So R tangent of 75 would be equal to 23. Get rid of the tangent by dividing. Again, make sure the calculator is in degree mode, and we would find that our R is equal to 6.16, and our speed, in this case, our rate was given to us in knots. So you may ask yourself, does that speed seem correct? Well, if my law enforcement boat is traveling at 23 knots, what I do know, if I'm a smuggling craft, is that I'm probably not trying to be spotted or be heard, so I'm probably going to be traveling at a much, much smaller rate of speed, because I don't want to, rev the motor and let anybody know that I'm out there smuggling whatever it is I'm smuggling. So it makes sense that the speed is much less than what the law enforcement boat was. And so that would be how you solve this problem.